Hello friends, welcome to the third part of this video series on electronic systems and subsystems. In this video, we will discuss about the signal processing subsystem in an electrical system. We have already covered the input and the output unit in the previous videos. So if you have not watched them, would recommend watching the previous two videos before continuing to watch this video. The first processing subsystem that we are going to look at is the drive. The voltage of the signal generated by most of the input sensors are often insufficient to drive the output device directly. Therefore, we need an additional unit which we call drive to boost the input signal and drive the output device like lamp, LED or fan. So we always need a transducer drive before the output device. There are two types of drives you will need to know. The first one is transducer drives, which contain a component called MOSFET. They are generally used to provide large power. That is, they provide larger voltage and current to drive the output device like motor and solenoid. The other type of drive is a transistor switch, which contain a NPN transistor. We will study about them in the later videos, but it's basically an electronic switch and provides smaller current to drive smaller output devices, something like LEDs, buzzers, and are relatively cheaper. The second type of signal processing unit is called logic unit, which is also called as digital processing unit because they operate on digital input signals. As we discussed in the previous video, the digital signal can only have two voltage levels, that is high or plus 5 volt and low or 0 volts. The high level is also called as logic level 1 and the low signal level is also called as logic level 0. These logic unit basically include logic gates, which are the decision-making unit of an electrical system. That is, they process the input according to a logic and produces the desired output. There are several types of logic gates, but we are going to study only 3 of them. The first one is AND gate, where the output goes high only when both the input signal goes high. That is, output is logic level 1 only when A and B input are 1. In the slide, you can also see the pin diagram of a typical AND gate IC on the right hand side. Generally, you have a notch and a circle slot. Right? You have a notch and a circular slot which is cut for a purpose. And what is the purpose? So the pin number starts from this circular slot. Okay, you can also see in the pin diagram, the first pin is the one next to this circular slot. and the remaining pins are numbered in anti-clockwise manner. Okay. The second logic gate is the OR gate, where the output signal goes high when either A or B or both inputs are high or 1. Okay. So A or B, that means either A is 1 or B is 1 or both of them they are 1, then only your output will be 1. The third logic gate is called as NOT gate or an inverter. As the name suggests, it reverses or inverts the input signal as its output. That is, if your input is 1, the output will be 0, and if the input is 0, the output will be 1. Now, coming back to the signal processing unit, there are a few more type of processing unit like delay, latch and comparator unit. The delay unit, as its name suggests, introduces a delay into the signal, which is of predetermined duration, right? A fixed duration. At the end of the set time, the signal returns to its original state automatically. Example, an external security light triggered by the movement of an object, right? You might have seen some security external security light which is triggered by the movement of an object, and it stays on for a couple of minutes before being switched off automatically. Okay. The second one is the latch unit. It is used to keep a signal on indefinitely until a reset button is pressed. Okay. So the difference between a delay unit and the latch unit is, delay unit, it will keep itself on for a fixed duration and then automatically it will turn off, whereas latch unit, it will remain on indefinitely until you press a reset button. The third type of unit is the comparator unit, which compares the analog input signal with a reference voltage. If the input signal is larger than the reference voltage set by the dial, the output is high. If the input signal is smaller than the reference voltage set by the dial, the output will be low. Okay. So this comparator unit compares your input signal with a reference signal. Okay. And if your input signal is higher, your output will be high, higher than the reference voltage, then your output will be high, and if it is smaller than the reference voltage, the output will be low. So the comparator converts an analog input signal into a digital output signal, right? So digital output signals, they only have two states, high and low. So as you can see, the comparator converts the analog input signal into digital output signal, and they can improve the sensitivity of a system when only a small change in analog signal occurs. Okay. It is also used to improve the sensitivity. Lastly, these are the steps for designing an electronic system. The first step is to decide or select the appropriate input unit for a system. Then select the appropriate output unit. Then decide which processing unit will be required. Now in the fourth step, we then draw a block diagram to show the interconnection of the input, processor and the output units. The block diagram or these units are generally implemented on a software like Control Studio, which you might have also used before. So using the software, the block connections of the system is tested and any changes are made if required. So this is the end of lecture 1 on electrical systems and subsystems. As mentioned in the first video, I will be discussing some of the GCSE exam questions, right? So in the next video, we will discuss some GCSE exam questions from this topic and will also draw some block diagrams. So in the GCSE exams, you are asked to draw, or basically a block diagram is given and you have to select the appropriate input, output and the processor unit and put it in that block diagram. Okay, so that kind of a question comes in the GCSE. So we will have a look at those type of questions. Okay, so thank you for watching this video and see you in the next one.